In today's fast-paced digital landscape, efficiency is paramount for enterprise applications. As businesses scale and user demands soar, the ability to process information swiftly becomes a critical differentiator. Enterprise JavaBeans, or EJB, a robust server-side component architecture for Java, plays a pivotal role in building scalable and robust applications. Within the EJB ecosystem, the concept of local home interfaces emerges as a key player in optimizing performance and streamlining interactions between components residing within the same Java virtual machine, or JVM. Imagine a bustling enterprise application handling thousands of transactions per minute. Every millisecond saved in data retrieval, processing, and communication translates into tangible gains in overall efficiency and user experience. This is where local home interfaces shine, providing a direct and streamlined pathway for EJB components to interact within the confines of a single JVM. By eliminating the overhead associated with remote communication, local home interfaces pave the way for faster and more responsive enterprise applications. As we delve deeper into the realm of local home interfaces, we'll uncover their inner workings, explore their lifecycle management, and illuminate their significance in the grand scheme of enterprise application development. Through practical code examples and real-world scenarios, we'll gain a comprehensive understanding of how local home interfaces empower developers to create highly efficient and performant enterprise solutions. Join us on this journey as we unlock the secrets of harnessing locality for enhanced efficiency in the world of EJB. The following sections will provide a comprehensive overview of local home interfaces, their role in enhancing Java application efficiency, lifecycle management, and the benefits of choosing local over remote interfaces in specific enterprise scenarios. By the end of this exploration, you will be equipped with the knowledge and insights to leverage local home interfaces effectively in your own enterprise application development endeavors. At the heart of the EJB framework lies the concept of a home interface, a crucial element that acts as a factory for creating and managing EJB instances. Home interfaces come in two flavors, remote and local. Remote home interfaces cater to interactions between EJB components residing in different JVMs, often across a network. On the other hand, local home interfaces are specifically designed for scenarios where EJB components coexist within the same JVM. Local home interfaces provide a streamlined mechanism for EJB components to interact without the overhead of network communication. They essentially act as a direct line of communication, allowing components to invoke methods on each other swiftly and efficiently. This direct interaction translates into significant performance gains, as the need for serialization, network transfer, and deserialization of data is eliminated. To understand the essence of local home interfaces, let's consider an analogy. Imagine two departments within a company, say marketing and sales. If these departments were located in different buildings, communication might involve emails, phone calls, or even physical meetings, introducing delays and inefficiencies. However, if these departments were situated in the same building, communication could occur through direct interactions, such as face-to-face conversations, resulting in faster and smoother collaboration. Similarly, local home interfaces act as the shared building for EJB components within the same JVM, enabling swift and efficient interactions. This direct communication paradigm is particularly beneficial in scenarios where performance is critical, such as high-volume transaction processing, real-time data analysis, and other resource-intensive operations. Local home interfaces play a crucial role in streamlining access to EJB components within the same JVM. They provide a well-defined contract for creating, finding, and removing EJB instances, ensuring consistency and ease of use for developers. By exposing specific methods for these lifecycle operations, local home interfaces abstract away the complexities of managing EJB instances, allowing developers to focus on the core business logic of their applications. Think of a local home interface as a concierge at a hotel. Just as a concierge assists guests with various services, a local home interface facilitates interactions with EJB components. It provides methods for creating new EJB instances, akin to a concierge reserving a room for a guest. It also offers methods for finding existing EJB instances, similar to a concierge locating a guest's room. Furthermore, a local home interface provides methods for removing EJB instances, analogous to a concierge checking a guest out of the hotel. This well-defined set of operations ensures that developers can interact with EJB components in a consistent and predictable manner, simplifying the development process and reducing the likelihood of errors. By streamlining access to EJB components, local home interfaces contribute to the overall efficiency and maintainability of enterprise applications. They provide a clear and concise way to manage EJB instances, reducing complexity and promoting code reusability. This streamlined approach empowers developers to build robust and scalable applications with ease. The lifecycle of a local home interface is intricately tied to the lifecycle of the EJB component it represents. When an EJB component is deployed, its corresponding local home interface is also created within the JVM. This interface serves as the entry point for other components within the same JVM to interact with the EJB component. The local home interface provides methods for creating new instances of the EJB component. These methods typically accept parameters that are used to initialize the state of the newly created instance. Once an instance is created, it can be accessed and manipulated through its business methods. The local home interface also provides methods for finding existing instances of the EJB component, typically based on some identifying criteria, such as a primary key. When an EJB component is no longer needed, its local home interface provides methods for removing the instance from the container. This removal process typically involves releasing any resources held by the instance and marking it as inactive. Once removed, the instance can no longer be accessed or manipulated. The lifecycle of a local home interface mirrors the lifecycle of the EJB component it represents, ensuring that instances are managed efficiently and consistently within the JVM. This well-defined lifecycle management contributes to the overall stability and reliability of enterprise applications built using EJB technology. To illustrate the practical application of local home interfaces, let's examine a simple code example. Consider an EJB component representing a bank account. The local home interface for this component might include methods for creating new accounts, finding existing accounts by account number, and closing accounts. / local home interface for a bank account EJB public interface. Bank account local home extends EJB local home / create a new bank account. Bank account local create, string account number, double initial balance. Throws create exception / find an existing bank account by account number. Bank account local find by primary key, string account number. Throws finder exception / close an existing bank account void remove, string account number. Throws remove exception. This code snippet showcases a local home interface for a EJB. The interface extends the interface, indicating its role as a local home. It defines methods for creating new bank accounts, finding existing accounts by account number, and closing accounts. Each method throws specific exceptions to handle potential errors during execution. This simple example demonstrates how a local home interface provides a clear and concise way to interact with an EJB component within the same JVM. By exposing specific methods for lifecycle operations, the interface simplifies the management of EJB instances and promotes code reusability. In the realm of EJB development, the choice between local and remote interfaces hinges on the specific requirements of the application. Local interfaces excel in scenarios where EJB components reside within the same JVM, offering unparalleled performance due to the absence of network communication overhead. On the other hand, remote interfaces cater to distributed environments where EJB components are scattered across multiple JVMs, often residing on different physical machines. The decision to employ local or remote interfaces boils down to a trade-off between performance and flexibility. Local interfaces prioritize speed and efficiency, making them ideal for applications where latency is a critical concern. Remote interfaces, while introducing some performance overhead due to network communication, provide the flexibility to distribute components across a network, enhancing scalability and fault tolerance. Factors such as application architecture, performance requirements, and deployment environment play a pivotal role in determining the most suitable interface type. For applications operating within a single JVM, local interfaces offer a clear advantage in terms of speed and simplicity. However, for applications designed to scale across multiple machines or handle remote clients, remote interfaces become indispensable. Understanding the strengths and limitations of each interface type empowers developers to make informed decisions that align with the specific needs of their enterprise applications. By carefully considering the trade-offs between performance and flexibility, developers can optimize their applications for optimal efficiency and scalability. Local interfaces play a crucial role in enhancing the efficiency of enterprise applications by streamlining interactions between EJB components within the same JVM. By eliminating the overhead associated with remote communication, local interfaces facilitate faster method invocations, data retrieval, and overall processing, leading to significant performance gains. Imagine a scenario where an EJB component needs to access data from another EJB component within the same JVM. Using a local interface, this interaction can occur directly, without the need for serialization, network transfer, and deserialization of data. This direct communication pathway translates into reduced latency, faster response times, and improved overall application responsiveness. In addition to enhanced performance, local interfaces also contribute to improved resource utilization. By minimizing the need for network resources and deserialization operations, local interfaces reduce the computational load on the JVM, freeing up resources for other critical tasks. This efficient resource management translates into smoother application operation and enhanced scalability. By leveraging the inherent advantages of local interfaces, developers can create highly efficient enterprise applications that deliver exceptional performance and responsiveness. This focus on optimizing interactions within the JVM leads to a more streamlined and resource-efficient application architecture. Choosing between local and remote interfaces is a critical decision in EJB application development. While remote interfaces offer flexibility for distributed environments, local interfaces excel in scenarios where EJB components reside within the same JVM, providing unparalleled performance and efficiency. Understanding the specific use cases where local interfaces shine is essential for making informed architectural choices. One prime scenario for leveraging local interfaces is when dealing with tightly coupled components within a single JVM. If multiple EJB components require frequent interactions and data exchange, using local interfaces eliminates the performance bottleneck of remote communication, ensuring swift and seamless collaboration. Another compelling use case for local interfaces is in applications demanding high performance and low latency. For instance, real-time data processing, high-volume transaction handling, and other time-sensitive operations benefit greatly from the speed and efficiency of local interfaces. By minimizing communication overhead, local interfaces ensure that these applications meet stringent performance requirements. Furthermore, local interfaces prove advantageous in simplifying development and deployment. By eliminating the complexities of remote communication configuration, local interfaces streamline the development process, allowing developers to focus on core business logic. Deployment is also simplified as there is no need to configure remote connectivity, reducing potential points of failure. Local home interfaces offer a compelling array of benefits for enterprise application development, particularly in scenarios where EJB components reside within the same JVM. Their inherent advantages stem from their ability to streamline interactions, enhance performance, and simplify development processes. One of the primary benefits of local home interfaces is their contribution to improved application performance. By eliminating the overhead associated with remote communication, local interfaces facilitate faster method invocations, data retrieval, and overall processing, leading to significant reductions in latency and enhanced responsiveness. Local home interfaces also simplify development by providing a clear and concise way to manage EJB instances. By exposing specific methods for lifecycle operations, they abstract away the complexities of instance creation, retrieval, and removal, allowing developers to focus on the core business logic of their applications. Furthermore, local home interfaces contribute to improved resource utilization. By minimizing the need for network resources and serialization/deserialization operations, they reduce the computational load on the JVM, freeing up resources for other critical tasks. This efficient resource management translates into smoother application operation and enhanced scalability. In the ever-evolving landscape of enterprise application development, efficiency reigns supreme. As businesses strive to deliver seamless user experiences and optimize resource utilization, the choice of architectural patterns plays a pivotal role in shaping application performance. Local home interfaces, a cornerstone of the EJB framework, emerge as a powerful tool for enhancing efficiency by streamlining interactions between components residing within the same JVM. By embracing the concept of locality, developers can unlock significant performance gains, simplify development processes, and optimize resource allocation. Local home interfaces provide a direct and efficient pathway for EJB components to collaborate, eliminating the overhead associated with remote communication and paving the way for highly responsive and scalable applications. As we conclude our exploration of local home interfaces, it's evident that their significance extends beyond mere technical intricacies. They represent a fundamental shift in thinking, a conscious decision to prioritize efficiency and optimize interactions within the confines of a single JVM. This paradigm shift empowers developers to create enterprise applications that are not only robust and scalable, but also agile and responsive to the ever-changing demands of the digital world. By understanding the nuances of local home interfaces, their lifecycle management, and their advantages over remote interfaces in specific scenarios, developers can harness the power of locality to build highly efficient and performant enterprise solutions. As the enterprise landscape continues to evolve, the pursuit of efficiency remains a constant, and local home interfaces stand as a testament to the ingenuity of developers in their quest to create applications that are both powerful and performant.